A power more menacing than the H-bomb will be wielded by the first nation that learns how to use weather as a weapon, by Captain Howard T. Orville, United States Navy retired, as told to John Cord Lageman. Captain Orville charted the weather for the Doolittle raid on Tokyo and was a weather advisor for the North African invasion and for naval operations in the Pacific. He was appointed by President Eisenhower to serve as chairman of the Advisory Committee on Weather Control that submitted its report a few months ago. The subject on this article is a highly controversial one. Meteorologists and scientists differ widely as to when, how, and what degree we shall be able to control the weather, but there is no dispute over the view that weather control merits serious consideration and research. Imagine all North America turned into 1,000 dust bowls where no green things grows. Fierce winds blacken the sky with dust clouds. Great lakes recede into swamps. The mighty Mississippi dwindles to a string of muddy ponds. Or reverse the picture, Cleveland, Chicago, and other cities lie deep under the raging waters of the Great Lakes. The fruitful Mississippi Valley is one vast inland sea. Coastal cities from Boston to San Diego are ocean beds. These twin nightmares, with their concomitants of dying cities, disease, and famine, were the sober concern of a recent meeting of the Senate Military Preparedness Committee. On the stand was H-bomb physicist Dr. Edward Teller, who testified that the United States could be beaten without war if Russia was first to control the weather on a global scale. He wouldn't be surprised, Dr. Teller told the committee, if the Russians did achieve such control during the next 5 years, or if it took 50. Control of Earth's weather and temperature is within the realm of practicability now, says Dr. Joseph Kaplan, chairman of the International Geophysical Year. These and other scientists make it clear that weather control is a challenge to be faced in our lifetime. Used wisely, it could turn the Earth into a Garden of Eden. As a weapon, it could be more disastrous than nuclear warfare. How can we change the weather when we cannot as yet even predict it with 100% certainty? Although research on both fronts is interdependent, it is hard to say which may come first. Bear in mind that medical science can now prevent polio and cure pneumonia, while still unable to cope with the common cold. Cloud seeding, the first method that comes to mind for controlling weather, is of little importance because it is effective only in limited areas under favourable conditions. But present knowledge lists 7 possible ways of changing weather on a global scale. Rockets spread gas clouds to increase or decrease the amount of solar energy reaching the Earth. Electronic bombardment of the ionosphere to alter its electrical charge. Controlled thermonuclear reaction to heat great areas of the atmosphere. Reflectors on space platforms to concentrate the sun's rays on the Earth. Heat absorptive substances spread on the polar ice caps. Dye, oil or vegetation on ocean areas to alter their reflective properties. Chemicals on the ocean surface to effect evaporation and thus rainfall. All these methods would regulate the distribution of heat in different parts of the Earth's atmosphere. This is the basis of global weather control. Visualize the atmosphere as a tremendous solar battery, constantly being charged with 127 trillion horsepower of energy every day in the form of ultra-shortwave radiation from the sun. The upper atmosphere filters out some of the harmful rays, but most pass through with no effect. The Earth absorbs their energy, is warmed by part of it, and transmits the rest back to the atmosphere as heat. Because this heat is in the form of infrared rays of far longer wavelengths than sunlight, much of it is trapped by the atmosphere and stored in water vapor or clouds. But this action is not uniform. Some parts of the Earth absorb more sunlight and radiate far more heat than others. Ice and snow reflect most of the sun's energy back into space, where it is lost to Earth forever. Deserts, even the hottest ones, also bounce back most of it, but oceans and forests absorb the major part and pass it back to the atmosphere. This spotty action of the Earth's surface causes uneven accumulations of energy in the atmosphere. Wind and weather are the result, as this uneven heat distribution seeks equilibrium. What leverage can we exert in this gigantic weather mechanism? Can we never expect to control the sun, which is the source of all our heat? But new knowledge of the upper atmosphere, now being gained from rocket flights and satellites, may enable us to control the amount of solar energy that strikes the Earth. Air Force scientists are already experimenting with sodium vapor ejecting from jet planes to intercept solar radiation. Other gases would admit solar radiation but trap heat reflected back from Earth. The last half-century, during which we have burned huge amounts of fossil fuels, has shown what an increase in atmospheric carbon dioxide can do. The amount spewed from chimneys and automobiles in 5 decades has created so-called greenhouse effect, which has raised the Earth's temperature by an estimated 2 degrees Fahrenheit, a significant rise. This so far accidental result is already serious, according to Dr. Capt, and we must find means to counteract it. Melting polar ice will make ocean levels rise at least 40 feet and inundate vast areas in the next 50 or 60 years, he warns, unless atmospheric temperatures are controlled. Electricity plays a part in determining our weather. High-altitude data already available suggests. Of particular interest is the ionosphere, that electrically charged outer layer of the atmosphere that reflects radio waves back to Earth beyond the horizon of the transmitter. This negatively charged shell can be thought of as one plate of a huge condenser. The other plate is the Earth's surface, which is positively charged in relation to the ionosphere, serving as conductors between the two plates, and so tending to neutralize their charge. Are ions, air molecules electrically charged by cosmic rays or by Earth radiations? An increase in the ion content of the lower layers of the atmosphere increases the electrical leakage between the ionosphere and Earth. During the last few years, ions created by hydrogen bomb explosions have done just this, lowered the electrical potential of the air near the ground. There is some evidence that this boost in ionization has resulted in more lightning activity. We may find other ways to manipulate the changes in earth and sky and so affect the weather. One means might be an electronic beam to ionize or de-ionize the atmosphere over a given area. Controlled thermonuclear reaction may be a powerful instrument for effecting the heat balance in the atmosphere and so changing the weather. Enough heat to warm a city or even a continent is not beyond the realm of possibility. Once we succeed in releasing atomic energy from such plentiful forms of matter as seawater and granite, huge space platforms, which few doubt we will be able to put into the sky in the next decades, would make it possible to mount huge reflectors or lenses to focus the sun's rays at any desired spot on Earth. Such heat beams could warm other cities or set them on fire. Perhaps Senator Lyndon Johnson had this in mind when he told the assembled House and Senate recently, "From space one can control the Earth's weather, cause drought and floods, change the tides and raise the levels of the sea, make temperate climates frigid." Changing the weather from outer space or with nuclear heat plants may seem more fantastic than these proposals really are. The space age has just begun. Our human imagination is still earthbound. For centuries, mankind has practiced a form of accidental and usually detrimental weather control by cutting down forests, draining lakes and swamps, and exhausting the fertility of farmlands. All these have increased the wasteful reflection of solar heat back into space, cut rainfall in some regions, and helped to create deserts like the Sahara. But there is a constructive hint in this. Change reflective properties of big surface areas and you influence the weather. Alaskan farmers even now add an extra 2 weeks to their short growing season by spreading lamp black on snow-covered fields and using sun reflectors to speed up melting. An untreated snow or ice field absorbs only 10 to 20% of the sun's rays. A blackened one absorbs 70 to 90%, melts faster, and warms the soil. New strains of cold-resistant cereal grasses are extending the green belt farther north in the subarctic regions of Russia and Alaska. This increases heat absorption, delays formation of a snow blanket in fall. Russia, having much territory in the subarctic, has carried cold weather farming much farther than we, because her major rivers flow northward and she is landlocked to the south. Russia has put tremendous effort into research on making frozen lands habitable and finding a sea outlet through ice-locked northern harbors. In such vast areas, the spreading of pigmented substances over ice fields, even by plane, can have little effect, but a heat-absorptive chemical fog spread over uninhabited ice fields by prevailing winds might someday make it possible to melt the polar ice cap. One result of that would be the sinking of our east coast cities beneath the Atlantic and the transformation of the Mississippi Valley into a huge inland sea. Water covers 2/3 of the Earth's surface. Altering its reflective properties would influence weather in various parts of the world. About half the heat energy absorbed by the oceans evaporates water that travels as clouds to pour rain on distant land areas. Seawater tagged with radioisotopes from H-bomb fallout has enabled us to learn that certain regions of the Earth get most of their rain from specific parts of the ocean. In the doldrum belt near the equator, steady evaporation of ocean water stores up tremendous accumulations of heat energy in the atmosphere, instead of dissipating itself in local and relatively harmless squalls. The tropical atmosphere becomes super-laden with energy until it releases its fury in a hurricane. Scientists believe that if we could break up the continuity of the reflective sea surface with patches of dye, floating islands of marine growth, or burning oil slicks, such a colossal overall buildup of energy could be avoided. Smaller concentrations would dissipate without harmful results. There are several chemicals which, when spread over the surface of water, drastically speed up or retard evaporation. A film of kettle alcohol, 1 molecule thick, for instance, substantially cuts down evaporation. Certain detergents speed up evaporation and cloud formation. Spread in large enough amounts, these chemicals could produce changes in the rainfall either to flood certain parts of the Earth or to turn them into deserts. The Russians may be ahead of us in weather control, and this worries our scientists even more than the technical problems involved. I shudder to think of the consequences of a prior Russian discovery of feasible weather control, says Dr. Henry Houghton of MIT. Unless we remain ahead of Russia in meteorology research, the prospects of international agreements on weather control will be poor indeed. An unfavorable modification of our climate in the guise of a peaceful effort to improve Russia's could seriously weaken our economy and ability to resist. We cannot trust to luck that we will be first to control the weather. The technical problems are staggering, and there is much research ahead before we can get results. It may be later than we think.